here at Team 7710. My name is Peace. I'm a sophomore and this is my first year in robotics.
My name's Allison. I'm the co-captain and this is my second year in robotics.
Hi, my name's Jen. I'm a junior and this is my first year of robotics.
Hi, my name's Asta. This is my first year in robotics.
Hi, I'm Olivia. I'm a sophomore and this is my first year in robotics.
Hi, I'm Booker. I'm a freshman. This is my first year in robotics.
Hello, I'm Trevor. I'm a senior and this is my fourth year in robotics.
Hi, my name is Eric and this is my second year in robotics and I'm a junior as well as co-captain.
So, one great thing that our team has is that we have two co-captains, which is really efficient because many of us are in our first year of robotics and we always need someone to turn to. So, this is especially good because she's very good with organization. She's one of our co-captains, and so she's always there to make sure we're on top of everything. We're doing everything right. If we have to take apart the robot for something, we're on schedule. He's very good with mechanics and coding, and that's just great.
He's terrible with
No, but he's very good with mechanics and coding. But she's good with mechanics also. Asta is very good with the notebook, making sure everything's down there and we're all on schedule. Olivia's very good with side rollers. Booker, mechanics also. Trevor, mechanics, and especially good with tools. You need him to cut sheet metal, he'll cut it, drill, whatever. And so I work with mechanics and whatever else needs to be done because there's stuff to be done with robotics. So. And then there's also our enthusiasm. And we do lots of stuff just to make sure we're all excited and pumped up about the team. When we wear the morph costumes, and then we wear masks, and then we usually chant this little thing that we do, and it's just a way to just excite ourselves about our team. Just have fun.
Can we hear the chant?
You'll hear it at the end.
Yeah, we can do it at the end. I think about to laugh. And also, really quick, we have three members that aren't here. They also include Philip, Aradia, and Jonathan. And they're both, Philip is good with notebook, and Aradia and Jonathan are also good with mechanics. Aradia especially shadows. Go ahead.
We have many different methods of communication within our team to keep up the team spirit and stuff. Our biggest one is Facebook. We have a Facebook group for our robotics club that includes present members and past members, and this gives us a chance to spread ideas that we come up with when we're not meeting, or just ideas we forgot to mention. We also have a Facebook page. This allows for the public to see us. It contains links to our website, to our YouTube channel, and also contains our email and our meeting times, as well as our address, in case anybody wishes to come and observe us. We also have a Facebook group for all the FTC teams in Florida. This allows for all the teams in Florida to share ideas over a simple network rather than through email, or just keep their ideas one-on-one, because with email it's hard to have a group email. We also have a newsletter that we send out to our sponsors every month that we write, and it gives updates to what we've been doing this past month, what we're doing, what upcoming events we have, what we might need in terms of donations. We also have a YouTube channel which allows us to show our practices, our prototype testing, as well as our matches during competitions. We have a team that videos our matches while we're competing. Also, here is Jennifer to talk about strategy.
Okay, so once we found out what the game is going to be for this season, we all sat down and we started brainstorming. Okay, we're going to work on hanging, scoring cubes, flag spinning, and we decided to focus on scoring cubes and flag spinning. However, as the season... Why? Why? Well, we just figured that, scoring cubes, because for us, we wanted to focus on that because it's all the little points that matter sometimes and can make the difference. And flag spinning, we just were worried about the weight of the robot and the stress, so we figured flag spinning might be a little easier to focus on. However, once the season progressed, we were like, we have a 1:27 ratio for gears, so we decided to focus on hanging instead of flag spinning. And as we were in the pit, we definitely worked with the other team, our alliance team, and we tried to focus on our strengths and weaknesses. For example, if they could use flag spinning, we're going to be hanging. And also during autonomous, we tried to see what they can do too. We can either park on the ramp or we can do the IR beacon. Also during autonomous, our mechanism can flip out and prepare us to score cubes. So it kind of takes a lot less time, so we can focus more time during tally-out to score cubes. And while we're going to the pendulum, we definitely raise our arms, because you don't want to sit there trying to raise it while your time is ticking down. And we have a back flap here. And however, there are some communication errors. The person controlling the arm was controlling the flap, the back door. However, we realized we could gain more accuracy if the person of the drivetrain could control that. And that's basically it. Austin, you can go ahead.
Okay, for the process of development and design, as Jennifer said, we have to first decide on what we wanted to focus on. And as she said, we focused on flag spinning and cube score. So we started off the season by everyone individually designed what sort of cube collector they wanted. Since we weren't limited, they gave us no limitations on as to what it should look like, what dimensions it should be in, any of that. So everyone created designs based on things they've seen in real life. So we have some claw designs as well as one referencing a bulldozer, because these are things they've seen in real life and they feel like it would be effective. And after that, we went around and discussed the pros and cons of each of their designs and came up with a conclusion as to which design would be the best. And we decided on side rollers. And from that, we began prototyping. And with prototyping, we not only got to see the flaws of the design, but also its potential and what was hindering its potential. From that, we were able to improve on that design even further, and each improvement was recorded into the notebook. And these improvements, especially structural changes, were drawn out in hand drawings, and hand drawings were more useful since we were able to emphasize certain parts of the design rather than just a brief overview of everything. And also, along with real life influence, we also have influence from school. So we were able to use things we've learned in school, such as Pythagorean theorem, for example, with measurements and other aspects.
Quick question. You said that hand design was more useful than what?
Versus CAD at this point in time, since it was quicker right now.
Makes sense.
Okay, so if you look at a robot, you're probably wondering what, like, these are side rollers, but they kind of look different. So what we had done, we had mimicked, you know, a car wash has these side rollers that wash the cars and get all the dirt off. Well, this is kind of like that, but instead of washing cars, we square cubes in. So it's very different than anyone else's that they have done. It's pretty cool. We're using these flaps, get them in, and it's an awesome idea to get cubes in because it doesn't get stuck anymore because it'll be duplicated and it won't get stuck in between. And then another thing is, once we were about to go hang, we would often go high and then bring it all the way back down, and then we would often get a problem where we would go too far down and then this entire thing will come up, and that was a big problem. So what we had done is we created this, which is an inhibitor, so that we could, it stops right when it gets to this metal sheet. And then another problem we often faced was when we were driving down to go get cubes, we would get stuck in here and we wouldn't notice, and we'd get a 5-point penalty for that. So we created a ramp so it would fall off, and then it can't really get stuck on the inhibitor anymore, so it's a pretty good way of doing it. And then this right here is our servo arm for autonomous, which helps score the IR beacon. It's pretty efficient, and then like Jennifer said, in autonomous, the arm will come up and then go back in, and we don't even have to worry about it. Another different thing that we have is this kind of trapdoor. Like in movies, they have these trapdoors. This trapdoor is, it's different. It has, we at first had a wire, a rope connecting from one of these holes and then connected to the bottom so that it could open it up when you were at a certain height. But that seemed to be inefficient. It would often miss. So we created 2 servos to open the door.
Well, basically, we have this back door. We have this back door right here that's used to hold the cubes, and these 2 servos right here. One works at the actual back. One works at the actual back door to hold the cubes, so that none can fall out, and one works as a lock because the 2 DC motors would either push the cubes out or bring more cubes in, which is why we have a lock in the actual back door right here. And right here, we have 2 hooks that work for lifting, and they're efficient at lift.
As they said earlier, we realized that our gear ratio was enough for us to hang. So right here, this gear has 3 times as many teeth as this gear does, so the gear ratio is 1 to 3, 1 to 3, 1 to 3. So our total overall gear ratio is 1 to 27 torque. So that's plenty of power for us to back up and hang, and that's why we're such an efficient hanger.
How heavy is it?
Huh?
How heavy is the robot?
We haven't really weighed it, but I guess I'd have to say
He's good.
10, 15, somewhere around there. At our first our first drivetrain had Omni wheels in the front and the back, but at our first competition we realized that we would get pushed around easily. So we changed the back wheels to normal wheels, and so we have the middle and the back wheels for traction, and the front wheels for maneuverability. Before, we had aluminum C-channels right here, but with the flip-out mechanism, they would take a lot of the brute force from it coming out, and so they were bending and getting misshapen, and so it wasn't working right. So in my welding class, I fabricated 2 1/8-inch steel C-channels, and so that everything is fine now. Eric, did you want to?
Yeah, I turned it on just now. Turn the server off. There you go. Bring the arm up.
That was the biggest funny voice.
Our back door works in sync, so in our code we have it written that the servo lock will raise momentarily right before the back door does. And during autonomous, I'm going to bring it all the way down.
Oh, we're going to fold it out. Okay, go ahead. Sorry.
During autonomous, as you've seen, it was flipped in like that. This servo arm acts as a locking mechanism to keep it in. When it comes out during autonomous, so does this. So that way we're ready for tele-op, score cubes and such. We do many things for community outreach, such as we have a t-shirt cannon that we built in our spare time in the club, and we take that to our home football games and we shoot t-shirts and drawstring backpacks into the crowd, and it really gets them amped up, and it raises awareness for other clubs in our school because we shoot their shirts, as well as our club and First in STEM. Gets people excited and people come in wondering about it, and so to join the club. We've also, earlier this year, we went to the Tampa Bay Inventors Council, and we talked to ex-Shark Tank member Kevin Harrington and other inventors, and talked about how they invented their product and how they plan to market it. We also hosted the first FTC competition of the year at our school, and we went to the Things by the Sea Festival earlier this year, where Middleton, Duct Tape, and ourselves demonstrated our robots, and there were other STEM-related projects that were demonstrated, where we also befriended a member of USF's BattleBots team, and later this year we're actually going to do BattleBots.
Okay. I'm just going to talk about the other community outreach activities we did and give a quick summary. One of the other things we did is we visited the Tampa General Hospital in the pediatric department, and we basically took our robots. At that time, it was the beginning of the FTC season, so we were only able to bring drivetrains that we had that weren't programmed yet, but we were able to bring our FRC bot and Vex robot, and we let the kids drive the robots and things like that and learn about STEM. So eventually they could go into that career, or they know what it is and they can see it in real life. Another thing we have is, Allison mentioned earlier, we have our Hydra website. And our Hydra website gets updated weekly on different updates of the team that has occurred or different design changes we have. And through that Hydra website, we have about 30,000 followers that 30,000 views that we've got in the past 2 to 3 months.
Who does the update on your team?
It's a combination between Allison and I. Okay. Yes. And including that, Allison also mentioned YouTube page, and I guess you want to also say that 7710 has a total of probably 10 or 11 videos on there that we've shown on our design. And in all, we've had probably about 23,000 views of just those designs. And we've been contacted by teams all around the world, including one in New Jersey. It was a rookie team that asked for our help. So now we're mentoring a team in New Jersey, which is pretty cool. Also, we have mentors that come in. For example, a mentor named Mr. Jordan, which is Jennifer's dad. Coolest guy. He likes Dr. Who, which is anyway. He is a microwave engineer at Track, correct?
Yeah.
And he comes in and just helps us with our design ideas and, brings up any flaws or changes that might need to be made before we run into them. So it helps us with eliminating time in building season. Yeah. And now I'm going to have Allison talk about funding.
We have about 2 minutes.
Okay. So funding, just a quick synopsis. We have multiple different methods and outlets. We have a Kickstarter. We just started a Kickstarter to collect funds for FTC teams. We also had a concession stand when we hosted the competition, the FTC competition. And we also held a Robocue at the beginning, our annual Robocue, which introduced the families of our team members to what we're doing in robotics. And it gave them a chance to see where their funds were coming when it was being used. Thus, we got a lot of donations from Robocue from their families because they were able to see what we were doing.
Okay. And last thing we're going to mention is another source of funding is grants. The team has written several grants, including Draper Laboratories, Naval Research Institute, and National Instruments. One of our mentors, actually, my mom, who is a CEO of a local nonprofit, came in. She's a grant writer. She taught us how to write grants. The student body then went up after we found the deadlines and wrote several different grants. We've had bonus meetings at others' houses and Skype calls and Facebook chats just to make sure we were done for the grant. The robot itself, in total, cost about $1,700. And the team itself, our true budget, which for everyone on the team, because we are one big team, Hydra, is $32,000. Now that's a lot more than we actually have. So there's a shortfall. And we have the budget here if you want to see it. This is the personal budget for 7710, and this is the one for the whole team itself. So yeah.
Great.
Yeah, okay. They're waiting for you. That was the subtle hint we get. Good. Any good questions? Great, guys.
Yeah, you covered it all very well.
Thank you. Thank you. Yep. Awesome. You guys. Uno, dos, y tres. All right.
Thank you.